Unity just released a new CLI that gives you the ability to install, build, and automate the engine from the command line. For this tutorial, we're going to explore how you can control your game at runtime by adding the ability to use cheat commands to get your game quickly to a scenario that you need for testing. All right, so to install the command line, you can just hop over to the Unity documentation, which I have linked below. And within the Use Unity CLI page, there is the Mac OS command or the Windows PowerShell. I'm going to go ahead and copy the PowerShell command and then head over to my command line, paste that in. And then mine went really fast because I actually already have this installed. But if this is a fresh install, you're going to want to open up a new instance of your PowerShell. Now from here, you can type Unity and you can see a list of commands. The first thing that you're going to want to do is set up the pipeline. And what this will do is actually install a package within your project. So you can say pipeline, if I do list, you're going to see I should already have my instances running. If you do pipeline lists and you don't, it'll say 0 of 1 running. And then if you need to install it, you can do Unity pipeline install. And that's it. It's going to go through. You might need to pop over and pull up the engine and make sure that it does a recompile to pull the packages in. But then after that, you can do pipeline list and see it pop up. That's it. Now you're connected. So if you do Unity CMD, you can see a whole list of commands and you will probably see 140. I have 141 because I have a custom command that we're going to write together today. Now to run the commands, you can see there's different parameters that are here. I'm going to show you an example. We're going to do Unity CMD screenshot and we're going to set the parameter of view to scene. And we're going to take a screenshot of that scene. If we come over, this is what the scene looks like and the screenshot, which is perfect. All right, let's do a custom command. And in this case, what I want to do is build out a command that lets me change what is in the inventory. I can more easily swap them out. This is something that I commonly did with cheat commands. So for some background, this is a sample project that is on GitHub. And there's a set of scriptable objects that define different items that can be within the inventory. What I've also built out is this concept of a save profile. And this is what's going to be loaded into my game at runtime to specify what goes into the inventory. So I created a new script called cheat commands. And a few things to note is that this needs to be a static class. And then for each method, you need to have it as a static async, and it needs to have the attribute of CLI command. Now this takes a couple of parameters. The first is the actual command. So in this case, we will type populate inventory. And then the second is a brief description of whatever this command does. Now you can specify any number of parameters that you want to have passed in within this command. Now, normally you would just say string save profile, but in this case, you need to have a CLI argument. The first parameter within the argument is the command itself. So we would type -- save profile, which you'll see in a second. The second is the description. The third is whether or not this is required. And the fourth is the default value. You can see here that I have two parameters, the save profile, in case I want to have multiple, and then whether or not I want to have the inventory cleared before I load in the items. And then from there, I just do my normal logic. So for my game, I check if it's clearing the inventory. If so, I raise an event to do that. Then I'm loading in the save profile through the addressable system, which is the recommended way to load in data in Unity 6. I'm awaiting for that to come back. And then if it succeeded, I'm raising the inventory changed event for each item that's in there. From there, I'm sending a response back to the CLI to say whether or not the profile was successfully loaded, and that's it. This will work within a project that is loaded in the editor. We will take a look at how you can make this work with a built game in a second. So once you recompile, you can come back over to the CLI and do Unity CMD. And again, you should see it populate. In my case, it's going to populate at the beginning. So from here, what we can actually do is Unity CMD editor play, and we'll see the editor go into play mode. Okay, and then from here, if we pull up the inventory, there's nothing in it right now. Let's go grab some keys real quick, and then we can show the two commands working. So now we've got some keys. So if we come over here, we can go, again, Unity CMD, populate inventory. We'll do save profile. We'll leave clear as false. Well, yeah. And now we can see the 4 items that were defined are there. If we do clear true, we can see that the other items were removed and we only have 1 instance of it. Now, this is great for testing within the editor. You can also do this in a built game. To do that, you need to add a component. So if you, I like to call mine, let's call it a console cheat. And then you can search for Runtime Pipeline Manager. In this case, I'm going to leave everything as it is, except for I'll check enable and builds. And then from here, you can just build and run. All right, so now we have the game. To send your command to the Unity project, you can do Unity command runtime, and then you point it towards the game. So in this case, it's called demo exe, and then we'll say populate inventory and all of the same stuff. So let's pull up the inventory so you can see. And we'll leave clear false even though we don't have anything in there. And you can see now it's able to connect to this project that is currently built. And that's it. So this is a very quick, brief example on how you can get going writing your own commands for the CLI to run within your game. And you can do this to run things yourself or even have your AI be more robust in its testing scenarios. Thank you for watching, and let me know in the comments if there are any other really cool use cases that you've come across. I'll see you next time.